we're looking at evaluating expressions in function notation. Fun stuff. Okay. Do you know how to do function notation? What do you know about it? You're not really finding a y-intercept. No. We're just solving the equation. This is basically saying if x was 10 and you put 10 into the equation, what does it equal? Yeah, so it's probably easier than you thought it was going to be. Yeah, so if we put in 10 where the x was, what is that equation going to work out to be? Exactly. Now it does make a difference obviously on which question we're looking at. This was g of 10, so I went to the g of x equation. If we look at b, it says f of 3, so we're plugging in that into the f of x equation, replacing x with 3. So what is that one going to give us? Good. H of a minus 2. J of 7. Two times 7 is 14. 14 plus 9 is, I don't think it'd be 26. 14, 23? Is my math failing me first thing this morning? Let me double check. I'm getting, I think 23. I'm going to use a calculator. 14 plus 9 is 23, yeah. It is 9 o'clock in the morning. All right. Find x if j of x equals 55. Okay, this is a different scenario. These were like, instead of having like the x of each of these equations, I'm just going to highlight it here, for example. This was replacing the x. I didn't mean to highlight the whole thing. This says find x if we know what g of x equals. So basically we're saying this g of x equals 55. That's what it's telling us. So then we have the other side of the equation, and now we have to solve for x. So we have a two-step equation. What do we do first? Exactly. And that leaves us, what's 55 minus 9? Good, and then that leaves us with 2x, so we have to do what now? Yep. So x equals, you got it. Okay, I'm going to have to go over here because I ran out of room. Let's try h. So again, if you get the g of x rather than like a g of a number, you're given the side of the equation, and now you're going to rewrite the other side, which is, where is it, minus 3x plus 1. Solve for x in this one. You got it. And so the last step would be to do what? So x equals, perfecto. That's a check mark. Okay, doesn't look like a check mark. Oh my gosh. Okay, all right, let's do I. We've got h of x equals minus 2. So we have one side of the equation. Let's plug in. What is h of x? 12 over x. What's the easy way to do this one? Or the shortcut, I should say. That would be your first step. Yeah, we can do it the long way. So long way is multiply both sides by x, so that, like, I'll do it, but I'll show you a shorter way after. When you multiply by x, those cancel. But now you've got to get rid of the minus 2, so now you would have to divide, right? So it ends up being division. So anytime I have my variable in the denominator, really the shortcut is I just swap places with these two. That's what you end up with anyways. So I don't necessarily, and it depends if your teacher needs to see those steps. I'm lazy. If I see this down below, I just trade places. All right, so 12 divided by minus 2 is? Wunderbar. Okay, and the last one, we have j of x is a 19 over 2. What was the equation for j of x? 2x plus 9? 2x plus 9. Okay, how do we solve this one? You could. There's a couple ways you could do this. Now, absolutely, you could subtract 9 from both sides, but if I do that, then I got to worry about common denominators, and I still have fractions. If it were me, I try to make it as simple as possible. Clear the fractions first. How can I get rid of the fraction? Yeah, so if we multiply everything by 2, that's going to go away on the left-hand side, and then we're just going to have 4x plus 18. Now I don't have to worry about common denominators and still having fractions and stuff. A little bit easier. Okay, what next? That's right. Now I would do that. And so that leaves us with 1 equals 4x. So what does x equal? Perfect. Okay. Translate the following statements into coordinate points. Okay, so when we're talking coordinate points, they just mean like those ordered pairs that have x and y. So when we look at kind of what we did here, when we have like j of x equals 55, what is that 55 really representing? Which one does it have to represent? Yeah, because we've got x over here, so it can't be x. So that has to be the y. So when you've got your function notation equaling something, that equaling something is, let's just highlight it in something nice and bright, this has to be y. So if I've got f of minus 1 equals 1, of the two, which has to be the y value? The 1. Which makes sense because if we look at what we did on this side, what went into the brackets attached to it, that was replacing the x. And so as a state of points, it would be minus 1 comma 1. Okay, what are we going to put for b? Easy peasy. And c, perfecto. And the last one, see, once you get it, right? It's just a matter of understanding which one's representing which variable. All right, now, yeah, sorry, I just did the last one because I knew you knew what you were doing by then. Okay. Given the function, given this graph of the function, find a of f of minus 4. Okay, so again, if it's f in brackets attached at minus 4, is this minus 4 an x value or a y value? X value, good correction. Okay, so on the x-axis, go to minus 4 and follow it up to the y-axis. What number are we going to end up at? One, two, three, 4. Are you sure? 2. That's what I was getting. 8, 2. Okay, f of 0. What happens there? it's still 0. When x is 0, the y is 0. F of 3. It's a little harder, that one, I think. And only because it doesn't cross right on the grid. So that's a little bit more tricky to say. What do you want to estimate that one is? That's what I was thinking. Negative, we're going down, right? So I would say like maybe negative 1.8. Okay, how about f of negative 5? Okay. X when f of x equals 2. So again, just like we did over on the right-hand side of this, when we get that function notation equaling something, that part that it equals is your y value. So we're looking now for if y is 2, what's the x value? So if I follow the graph up where y is 2 here, follow it over to your graph, it's not an exact point again. What would that x value have to be? It's not 0 because, right, it's lining up here somewhere. Yeah, that's what I was thinking. Okay, how about, so f of x equals 0. So that's saying y is 0. If y is 0, what's the x value? You got it. Okay, let's go on to the other. Any questions on that? Perfecto. Let's see your second page. Okay, what do we got going on? Ooh, parabolas. Good times. I like parabolas. That's not sarcasm either. Okay, what are the x-intercepts? Good. Now, I'm not sure whether they want them written as ordered pairs, possibly, or as just x equals. Either or is probably acceptable, but I'm going to go with what you said because I agree. The x-intercept happens at negative 5 and 0 and negative 3 and 0. Okay. Do you know what the axis of symmetry is? Okay, so an axis of symmetry, no, that's totally fine, is like, where do you cut this parabola? A parabola is this U shape. Where would you cut a U? Like if I was to, I'm going to give you a completely different one. Here's a lovely U. Here's my graph on X and Y. I'm just going to make this over here as my X and Y. I probably shouldn't draw one because my accuracy skills are not great. But let's just say this is 4. There's a point here. 3, 2, 1, 0. Let's say there's a point here. Let's say there's a point here. Okay, we're pretending this is equal. So basically, an axis of symmetry is what splits the U right down the middle so that it kind of cuts out what we call, this has two things. Right now, what I drawn here is a minimum. It's a minimum value because the parabola opens up, and so all the values are getting larger. If my parabola was to open down, like this, because that's probably, oh, it is coming up, then this would have represented, I'll use blue for this one, a maximum, because now all my values are smaller than that. That's as high as it reaches. So the way you get a maximum is if all parabolas have an x squared. You'll see that coming up if you haven't seen this yet. So the general parabola is just y equals x squared. If you get just a y equals x squared, what that looks like is the origin is at 0, 0. That's what we call the vertex. This is a vertex right here, that point where you reach that maximum or minimum. So in just this y equals x squared, which will be this equation, the origin or the vertex is at 0, 0. And it's because it's a positive x squared, it's going to open up. And I'm going to get a u that opens this way. Had it been a negative x squared, my origin is still 0, 0, but it's going to open down. So anytime there is a negative out front, you're looking for a u that's facing down. If you get a positive that's like there's no number so we know it's positive, then it's going to be opening up. And in which case, any positive x squared parabola has a minimum, any negative x squared parabola opening down has a maximum, because all the numbers get smaller. But the one thing that remains the same is the axis of symmetry is what splits it right down the middle. So in this case, for just in y equals x squared or y equals negative x squared, our axis of symmetry is just when y or x equals 0, because it's starting at 0. In this one, it went down here where my vertex was. So this one, the axis of symmetry was at x equals -4. So going back to your original equation, where we see the u, we see where it kind of starts to reverse its direction, where there would have been this imaginary line that splits it down the middle. That's your axis of symmetry. Yeah. And the other reason we know it's an axis of symmetry is because you get a mirror image, identical images on the left side and the right side. So the fact that you had an x-intercept at -5 and another one at -3, the point that separates them in the middle equally would have had to have been at -4. So even if you look at, like, if you look at this one, there's, what are the, we'll come back to the other ones in a minute. What was the x-intercept in these ones, in this one? Okay, so we had an x-intercept at 3, yeah, and 7. So if we think of the numbers, just even the numbers themselves, 3 and 7, what you could do is you could go, well, even, I mean, you can identify the middle point, but you could do 3 plus 7, but cut it in half, divide it by 2, because that has to split you right down the middle. 10 divided by 2 is 5. So it should be happening here at that 5. That's x equals 5. So if you don't, yeah, so it just depends on how wide your graph is. You can literally just add your x-intercepts, cut it in half. The middle has to go there. Make sense? Okay, we might as well, since we're on x-intercepts and symmetry, let's finish off this one and then we'll look at the other points. It sure does not. None. It is sitting way too high. Okay, what about our axis of symmetry? Okay, so that kind of, in this case, because there's no x-intercepts, I can't exactly add them and divide by 2. Unfortunately, you're going to have to go up to the vertex, that point where it reverses direction, and just see where it is. Yeah. Okay, so a vertex is the coordinates of that reversal of direction. It's that point on the u that creates that axis of symmetry. So the fact that you've already got the x value for the axis of symmetry, we know that the vertex, the x value, has to be -4. When we were at -4, what was the y value? Exactly, so that's our vertex here. Now, is this a maximum or a minimum? Good. Okay, let's look at the graph beside it. What is the coordinates of that vertex? Okay, maximum or minimum? Perfect. And the vertex of the last one? Perfect. Maximum or minimum? You got it. All right, domain and range. Now, for parabolas, it's super easy. The domain is the same for all of these, because as the parabola starts to create this U, over time it gets wider and wider and wider and wider. It's going to cover all values, both positive and negative. So what we would say is that the domain is all real numbers. It's going to be the same for all of these. All parabolas get larger over time. The range is the piece that changes because it has to do with a maximum or minimum. I don't have y values up here in 4s and 10s, or I kind of reach that breaking point at my maximum value of 1. At that vertex, when y was 1, that was the most I could do. So I'm going to say for y, the values are less than or equal to 1. What do you think we're going to put for the range in the other one? Greater than or equal to? Exactly. What about the last one? You got it. Okay, any questions on that kind of thing yet? All right, so now for these next questions, it says determine the coordinates of the vertex. To find the vertex, you're going to have to put this in vertex form. Have you learned how to do vertex form yet? Okay, no problem. Let's go over it. So basically what we want to do, I wonder if I want a new piece of paper. Maybe later. Okay, so what we want to do is we want to take a look at the first two, for all these questions. We start with just the first two terms. This one only has two, so I guess I'll look at both of those. So we start with the first two terms only. If we could, we would factor out, because the number one rule of factoring is to remove the greatest common factor. But in this first one, there is no common factor because it's just a 1x squared. This one, I could remove a common factor. What can come out here? Okay, so I could take out a 2, and then what would go back into the brackets, only with these first two terms? Yeah. So it depends on if you can remove a common factor. Now let's go back to the first one, then I'll explain this one after. This one we could not remove anything out of. So I still just have x squared plus 6x. So what I'm going to do is I'm going to write x squared plus 16. I think I said 6 a minute ago. 16x. And then what I want to do is I want to leave a space to add something. I knew I should have used more paper. And subtract something. This third term piece that's in here, let's highlight that in a different color. That's going to come and sit outside. So that plus 64 is not part of what's in my brackets right now. Here, I'm going to erase this factor piece for now just because I need more room. There. Okay, so we start by kind of setting up this new bracket with something plus, something minus. That something that goes in here is this number that we're going to divide by 2 and then square it. So that's going to be a lot to write, so I'm just going to write it here. Divide by 2 and then square it. And I'll just kind of shrink her down. extra small, maybe not that small, and I'll put it here, and then I'll put a little arrow as a reminder. That's going to go to our second term here. So what is 16 divided by 2 squared? What's 8 squared? 8 times 8. Okay, so we're going to have plus 64 and a minus 64 in both spots. That's the first step. Now what we want to do is we want to take, what's the best way to say this? The minus piece has to come outside now. I'm going to use a different color here. This is going to come to the outside as a minus 64. And I'll show you why I just didn't put it out minus later, but that's going to come on the factored versions. So that's going to cancel that out. What's left now is these three terms to factor. So in order to factor, I'm going to write it over here for a second. X squared plus 16x. Do you remember factoring from grade 10 at all? Okay. I don't think I'm going to teach you the full factoring because you really don't need it to find in Vertex Form. The simple solution for all of these is going to be simply take this number now and just divide it by 2. Don't square it. And 16 divided by 2 is 8, so this becomes, as factors, this would have been x plus 8 times x plus 8. If we FOILed this, just as a check, this would have been first terms, x squared. Outside terms, there's 8x. Inside terms, there's another 8x to make 16x. And then the last terms together, 8 times 8 is 64. So the fact that, and when it comes to vertex form, these are always going to be identical brackets. So I would rewrite this as simply x plus 8 squared. I'm not going to write it twice, just x plus 8 squared. We had a plus 64 and we subtracted 64, so that went away. So really, that's our final answer in vertex form. Now, how does that help us? It would have been, I wish there was actually something here because there's really a 0. And so when I put it into the vertex form, the x coordinate of my vertex is basically what's in the bracket, but opposite sign. So if you got a plus 8, then my vertex has an x value of minus 8. My y value would have come from, if these combine to make another number, which I'm sure the next ones will, then that's your y value. The fact that I don't have anything here, then my y value is 0. So that's the coordinates of your vertex. So if we know the vertex and visualize that, let's just say we've got a point here at minus 8 and our 0 is here. Where's that line of symmetry going to go? You can, right? If there you got 0 here, what's in the middle of the negative 8 and the 0? Yeah, so our line of symmetry is at x equals minus 4. It also asks for the y-intercept. Where is it crossing the y-axis? Okay, so we had, oh shoot, hang on, no, I already made a mistake. At least it's a small one. We had our vertex at negative 8 and 0, which is here. My parabola was positive, so just as a sketch, my parabola is going to look something like this. So my line of symmetry wasn't going to be at minus 4. My line of symmetry, as all the other questions were at where the x-coordinate was of the vertex, right? Because that's where, right? So it would have been at x equals minus 8, not minus 4. So at least it was only one thing we need to erase. Okay, so now I'm looking at what is my y-intercept? Where is it going to cross as this parabola starts to get large and open up? Where is it going to cross on this y-axis? If you have a y-intercept, what's your x value? Yeah. If you put zeros into the x's of this original equation, what's left? If you have 0 squared plus 16 times 0 plus 64, if these are all zeros, what's going to... not entirely, because there's something else not getting a 0. Like if this is a 0, yes, so the y-intercept would have to be 64. Okay, so that answers all of that one. Now I definitely need more paper, so let's screenshot this B and try this one. Oops, that's not a screenshot. I thought I pressed the buttons. Yes, I didn't. It's thinking. There it is. And let's not take up all my space. Okay. Alright, so I'm just going to go back to the first part, which is to remove the greatest common factor. You've already done that. We had 2x squared minus 2x. And remember that that third term sits outside the brackets. I don't make this stuff up. I just follow the steps. I couldn't tell you. Alright. Now, the second step is to now take what's inside the brackets and we're going to add some space. Remember, we want to add space to add and subtract something. We need to add something, subtract something. It's going to be the same thing as it sits inside the brackets. That something came from what we had to do to the second term. What did we have to do to that second term? Let's go back as a refresher. We have to divide by 2 and then square it. Okay, so if we were to divide this by 2, what's negative 2 divided by 2? And squared not negative 1, because if you've got negative 1 and you square a negative 1, what happens when you have negative 1 times negative 1? Positive 1. So we're going to have a plus 1 and a minus 1 in both those spots. Now, what we would do is we're going to pull that to the outside. To pull this to the outside, on the previous question, I was just able to write minus 1. But I can't just do that this time because there's something that sits out front of this bracket that, according to the distributive property, would have had to multiply to everything inside the bracket. So when I take it out, it has to multiply to that number that's out here. So it becomes minus 1 times 2 because of that. And so what I'm actually taking out to get rid of it is minus 2. Right? Minus 1 times 2 is minus 2. Okay, now we've done that. Now we're on to the factoring stage. And the factoring stage with everything in vertex form is going to be identical brackets, so we're just going to write it as a squared. We're going to have 2 of those identical brackets. And the easier part came from, remember the shortcut was just from, I'll go back, dividing that second term by 2. So when we looked at this, and I was factoring this, all I really needed to do was divide this by 2. And then that's the missing piece to give me x plus 8, which we just wrote as a square term. So when I'm looking at this, the shortcut is just divide that by 2. What do we get? So in here we're going to have an x with a minus 1. Which makes sense if we think back to last year grade 10 math. If I was to have FOILed x minus 1 times x minus 1, what would we have gotten? Right, because minus 1x and another minus 1x. And then my last terms together make, no, negative 1 and negative 1, the last terms, make the plus 1. Right, so that's where that came from. So we factored this trinomial to this. Minus 2 and minus 2 sat outside the bracket. What's minus 2 and minus 2? Good. And now we've got what we call our vertex form, so we can answer the question as to what is our vertex. So the vertex, what's the x value for the vertex? Okay, let's go back and take a peek. So on the previous question, remember, we want to take, if it's an x value, it's coming from the bracket because that's what's in with the x. But we reverse that symbol. So this vertex had an x of negative 8 because we had a plus 8 in with the x. The y value comes from what sat outside the bracket, but in the first question, we didn't have anything there. So this one, what would the x value be? 1, what would our y value be? Negative 4. Yeah, you're coming from the end piece for that. Okay, now that we have the vertex, what is our axis of symmetry? Good. I'm just going to go sim because I'm lazy. X equals 1, and why does my S look like a J? Oh, weird. Okay, and then the other thing we had to find was the y-intercept. What's the y-intercept? Yeah, because again, if x was zeros, and we put zeros in all this, that cancels out the first two terms, and the only thing left is the negative 2. Perfecto. All right, let's try another one. Boom, boom, boom. Okie-dokie. So, number 1 rule of factoring, start by removing the greatest common factor only from the first two terms. Yep, and I would take out the negative 2. So then what goes back in the bracket? Is it going to be plus if I have a minus 3 on the outside? Negative 4x, good. Now, I'm going to try to do 1 and 2 steps all at once. I don't want to rewrite it because I'm getting lazy. We're going to do the plus piece and the minus piece. We're going to leave that space right away. And then we'll put the minus 10 on the outside. All right, what's going to go into that plus and minus piece? How do I get the plus and minus piece? What do I do to that middle, that second term here? And okay, let me copy it over as a reminder. It takes a little bit to get it. That's okay. We want to divide by 2, but then square it. So let's put this on this page as well with another arrow. You'll get it eventually. And I'm going to give you an IXL link you can do to practice this vertex form as well. So if we divide by 2 and square that, what will we get? I says, pardon? Minus 4 divided by 2 is... minus 2. What's minus 2 squared? Minus 2 times minus 2. I hear you, but I'm ignoring you. No, I'm just kidding. Okay, minus 2 times minus 2. Repeated multiplication when we have an exponent. What happens when you've got something being squared? Those negatives become positive. Yes. Okay, so we need a plus 4 and a minus 4. All right, now the next part is to do what? Okay, and if I'm going to pull it onto the outside, what happens when there's a number out front? Think of that distributive property. You got this minus 3 to brackets, meaning it's technically multiplying to everything inside. So if I'm taking it outside, it has to multiply to it. So I can't just take out a minus 4 without multiplying it to the minus 3. So what number actually comes to the outside now? Yeah, plus 12. All right, we're on pretty much the last step now to rewrite this in vertex form. We want to factor, oops, I don't like that. We want to factor those first 3 terms. And that's going to give me an identical bracket when I look at this. But the shortcut was, again, just dealing with that second term. What would I do with that one? Divide it by 2. We just don't do the square it piece. So if I just divide it by 2, I end up with x minus 2. What does minus 10 plus 12 make? Good. All right, that is our vertex form. So what is our vertex? Not 0. Remember, the y value comes from what's outside. 2, 2. So that comes from the outside, and let's highlight maybe in green, which I think you've got that part already, comes from there. 2, 2. All right, what is my axis of symmetry? Good. Axis of sim, x equals 2. And what is my y-intercept? Perfect. Okay. Let's take a look at the next one. I always forget, and I've asked people, I need to start writing this down, but was your course all year long or is it semestered? It is. I'm going to actually start writing this down because I'm trying to think, like January is always like my busiest month, like it is, every spot has like been taken. So I'm like, I just want to know how many are continuing after February, so when I get new referrals, how many I can actually say, yeah, I've got room. So, while I quickly look for a pen, I want you to factor out the greatest common factor from those 2 terms. Oh, I got a pencil. I'm going to start taking a list. Okay, so do you have a preferred date and time? Okay, I'll see what I can do. Tuesdays, I always do 5 to 7, so it'd be 5 or 6. I'll have to check to see if they're all year long or not, though, but I'll write it down as preferred. Okay. Okay. All right, so when you factor out, what did you factor out? Good, and then what went back into the brackets? Good. Yes. Ooh. Yeah, no, never mind. I had just a mental brain fart there. Okay. All right, so we factored out that. I don't need to close, I don't have a third term, so there's nothing there. So we can go right to the plus and minus piece, but I have nothing to write on the outside of it. What is going to go into that plus and minus piece? Yeah. Okay, now we're going to take that to the outside, and to do so I have to do what? Okay, what is 1 over 2 times that negative 4? Okay, so that comes out, that is gone. Now let's rewrite our final equation. What is my identical factor bracket going to look like? Well, remember, I'm factoring the 3 terms here. The fact that it's a vertex form and I know it's going to be identical, we want to do something to that middle term. Which is basically the same on how I got this, I just didn't square it, right? I was just going to have to divide it by 2. And so that should have just been plus 2. Only when we do the plus and minus, we divide it by 2 and then square it. But when we do the factor piece, all I really have to go from here to here is just simply divide whatever's there by 2. We only had one number on the outside, so that was it, minus 2. So what's our vertex? Close. Remember, with the x, you have to reverse the sign, because it's what makes the bracket 0, essentially. So it would have been a -2, -2, yes. Okay, what's my axis of symmetry? Good. Axis of sim, x equals -2. And what is my y-intercept? Well, if I replace x with zeros, what's left? Zero. Exactly. So y-intercept of 0. Okay, all right, you have one more page here I see that you posted, and this is we're just going to graph it with all of that wonderful information we've done. So the first thing we have to do to answer all these questions is put it in vertex form. I mean, you could, I see they've done it with a table of values, so you could do a table of values. From there, you could probably identify it all, but to be completely honest with you, it's much easier to do vertex form. So that's what I would do. Because if you do a table of values, you never really know what x values to use. If you get it in a vertex form, you've got everything you need to graph it. So I'm going to ignore this whole table here. Okay, so what are we going to do first? Well, I've only got a 1 in front of the x squared, so I have nothing to factor out of it. Okay, so what are we going to start with? X squared, then what? don't forget, you still got to write the second term first, right? So we write the first two terms, then we have the space for the plus and minus. Okay, what's going to go into these plus and minus spots? Which is, and then squared is, if you got -1 squared, +1, okay, so 1 and 1 go into each of those. That third term of -3 just hangs out on the outside. Okay, what happens next? Perfect. And since there's nothing out front of the bracket, I don't need to multiply it to anything. Okay, what comes next? Yeah, because we simply divide that second term by 2. Okay, and what sits on the outside? Perfect. All right, what's our vertex? Remember where the x comes from. You got that kind of right, but don't forget you got to reverse the symbol on whatever is, because it's what makes this bracket 0. Right, so that shouldn't be -1, it'd be a +1, and the y value comes from what's sitting on the outside. Yeah. So 1, -4 is our vertex. Oh, that's a funny 4. Let's fix that. Okay, now that we have our vertex, what's my axis of symmetry? It's along like when you're looking at the U, you're looking along the x-axis where it's splitting vertically that U in half, so be cutting down the x. Like when we did these ones, when I'm looking for that axis of symmetry, it's splitting the U in half, so it's crossing the x-axis. We're looking, where is it crossing on the x? And it crossed wherever that vertex piece was. Yes, I think so. I lost my page. Here we are. Yes. Okay, so we would have, our vertex was at 1 and -4, so yeah, it would be at x equals 1. So if we plot our vertex at 1, -4, there's my vertex. I have an imaginary axis of symmetry here. I'll put some dotted lines just as a kind of a reminder. There's where it's gonna have that mirror image. Is this graph going to have a maximum or a minimum? Good, because it's a positive x squared, which means it's opening up. So all values are getting larger. So there is a minimum. It asks for a minimum, like usually we just say max or min. This actually says value, so I'm not sure if they're looking for that. And if they are, then we would say y equals -4, because that's where that y point is of the vertex, because we know it's opening up. That's the smallest the points are going to get. What's my y-intercept? Remember, y-intercepts come from putting zeros into those x's. Not -5. Oh, that's a bad looking 0. If this is 0 and this is 0, what's left? -3, yeah. Okay. X-intercepts. Okay, so we know we've got a crossing at the y at -3. If there's a point there, because there's symmetry, there's also a point here. which I already know the basic shape, but I haven't had a chance to go over basic shapes of parabolas. So I am going to review factoring very quickly with you in 4 minutes or less by the looks of it. Okay, if I wanted to factor this trinomial, I'm not sure how you learned factoring last year. I do it through what I call the box method. You've seen that? Okay, good. Do you remember how to do it? Okay. So whatever number sits out front of the x squared, you want to put two numbers that multiply to make that down the first column. So really there's like an imaginary 1 here. So I would just have 1 times 1. Then I would look for two numbers that multiply to make the end term of 3. I don't worry about the sign, it's just the number for now. The only thing that makes 3 is 1 times 3. So what we would do after that is I'd cross multiply. 1 times 1 equals 1. 1 times 3 equals 3. The next step would say, well, how do I add to that middle term, which now we include the symbol of minus 2. The only way to make that happen is how can I make a minus 2 out of these numbers? Right, and if that becomes negative, I carry it into this column. And now my factors pair up this way. So that becomes a factor bracket, that first column representing the x's. This didn't have any x's attached, but this column does. So this would represent a 1x with a plus 1. This one would represent a 1x with a minus 3. And so the reason that if we can factor this, this gives me my x-intercepts. What does x equal? What's x going to equal in this one? Again, don't forget to reverse it, because what makes it 0? Right? And what makes this bracket 0? X would have to be 3. So once again, we take the number, but we reverse the sign. So those are my x-intercepts at -1 and 3. And so I would have a point at -1 and 3. And now we can sketch our parabola. I really like parabolas. They're fun. Okay. Do you remember what I said about domain? What's our domain for all parabolas? All real numbers, right. What is my range going to be? You got it. So what I'm going to do is I'm going to post you, if you feel ambitious and you want to practice some vertex form, I'm going to give you a link on iExcel to do this. I'm even going to post one for factoring, because you should probably review factoring. Honestly, it's the easiest way if you're, like, as you get faster at it, than doing a table of values. If you feel you need another lesson, I actually did get one cancellation for tomorrow at 2:30. I'm just telling people if they're interested. Okay, let's go here. Learning. I'm just going to search. That's probably faster, I would think. Let's just go there. Vertex Form. Graph quadratics and Vertex Form. Okay, that's graphing. You started with writing equations, though. Oh, and the only problem is some of these go sideways. You haven't learned the sideways piece yet. Darn it. That'll be an issue. You can't. I can. If you come across one, it doesn't work. But you know what? I doubt it would do it at the grade 10 level. I'm going to drop down. Most people don't teach the sideways one. I don't even know why they put it on iExcel that way.